His legs, those legs, deserve closer attention. Each of them ends with a clawed toe capable of grabbing rocks and sedimentary rocks with equal accuracy. Joints are lubricated not with liquid, but with a protein gel that does not freeze. This bioantifreeze ensures the crab's mobility even at temperatures close to the freezing point of seawater. No robot created by us can compare with it in terms of frost resistance. If evolution ever created a tank that could think, it would look like Paralithodes brevips, the spiny Kamchatka crab. It's not just armored, it's architecturally protected. Every inch of this creature is evidence of how life turns into art under the pressure of circumstances. This crab does not inhabit shallow reefs or sunny shores. No, it thrives in the cold North Pacific Ocean, crawling along volcanic ridges and the muddy seabed, which shifts like ash when it breathes. Here, where the water burns like steel, the prickly Kamchatka crab reigns with patience and calm calculation. The uniqueness of Paralithodes brevips lies not only in its armor, but also in the mechanisms that are underneath it. Each of its 10 legs hides a system of microconnections so precise that engineers have modeled them on robotic limbs. What's the secret? Inside each limb segment, collagen and calcium form a two-layer joint that resists both compression and twisting. Imagine a limb that can lift a mass 10 times that of a body by bending in 3 planes. Evolution has done this without any blueprints. But the real story lies in his hands, or claws, technically speaking. The asymmetry is amazing. One paw is a crusher made in the form of a vise, and the other is a chisel honed to ensure accuracy. The right claw has jagged protrusions that can split clam shells, and the left one can cut sea cucumbers with surgical control. The nervous system is so subtle that each claw can act independently, like 2 minds in one body. Studies have shown that when one crab loses a claw, the other slowly reprograms its muscle response to balance the missing function. It's not an instinct, it's adaptive intelligence. If you like such deep-sea geniuses, don't forget to like, subscribe, and support the channel. Every click keeps the current flowing in this ocean of discoveries. Now let's take a look at his exoskeleton, one of nature's greatest engineering achievements. Under the thorns and plates of the shell is a layer of chitinous fibers arranged in the form of a cobblestone, a spiral pattern that is also found in mantis shrimp and bulletproof beetles. This structure prevents cracks from appearing, which means that when a predator bites, the force of the impact spreads through the shell, rather than destroying it. It's an armor that learns to absorb violence. And there's something poetic about it. The crab's shell doesn't grow with it, it has to shed it painfully and repeatedly. Molting is a moment of vulnerability. For several hours he remains soft, translucent, and defenseless, a creature that is reborn each time in its own armor. Many die during molting, caught halfway between life and protection. But those who survive become sharper, stronger, more sophisticated. It's not just biology, it's a metaphor. Nietzsche once wrote, "What doesn't kill me makes me stronger." The spiny Kamchatka crab literally embodies this phrase. There is another secret hidden under the shell: microsymbiosis. Small polychaete worms live in the grooves of the crab's shell, cleansing it of parasites and dead tissues. It's not a charity, it's a contract. The worms get protection and the crab gets hygiene. The ocean loves efficiency, and this crab has mastered it perfectly. And then there's the behavior. While many crabs are hiding, Paralithodes brevips is patrolling. It forages for food like a bulldozer, using its claws to flip over rocks and expose buried life. He doesn't just react to the environment, he changes it. In fact, marine ecologists have found that the areas frequented by these crabs exhibit a higher biological diversity, as the seabed is ventilated due to the constant disturbance. The spiny Kamchatka crab is, unwittingly, a gardener of the depths. But its elegance lies in the smallest details, in how its sensitive hairs pick up the vibration of the water, how its jointed legs can determine the direction of sound. His whole body is an instrument attuned to movement. When someone passes behind him, he doesn't turn his head, he feels the sound penetrating through his shell. It's not magic, it's evolutionary acoustics. Scientists studying the crab's nervous system have discovered an amazing feature. Each leg has semi-autonomous nerve nodes that can function even separately from the body. Simply put, legs remember movements. It is a distributed brain, similar to a network of small processors, each of which performs its own subtask. When we talk about biological robotics, we mean exactly that. The more you study it, the clearer it becomes that the Kamchatka crab doesn't just survive. It is optimized. Every joint, every spike, every claw is balanced between attack and defense, rigidity and flexibility, individuality and cooperation. And perhaps that's why this creature is admired by both biologists and philosophers. This is a paradox, a warrior who must destroy himself in order to grow, a tank built on tenderness, a system that survives through symbiosis. As Leonardo da Vinci once wrote, "Art is never finished, it can only be abandoned." Nature, in her ruthless engineering, never abandons her art, she just keeps molting. So the next time you see a crab prowling over rocks, remember, underneath this shell lies an ancient mind made up of muscles and memory, which has been perfecting for millions of years, molting in turn.